Assalamu alaikum. Assalamu alaikum. How are you, my dear students? Hope you will be in the best of health, wealth, and happiness. I welcome you all into my today lecture. Today is our lecture number 5, Unit 7, Chapter Properties of Matter. In my today lecture, I will explain to you elasticity, stress, strain, Hooke's and Young modulus. So let us start with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. Elasticity. Now, what is elasticity? Class, you have seen, and this is our common observation, sometime when you get a rubber band in your hands, then you try to, you rather play with it and you try to stretch the rubber band. And sometime when you get a spring, you compress or you stretch the spring. As you see, for example, look at the rubber band, this one, as you see, and when you just pull it get what it gets stretched, but when you release the force on it, then it get its shape back. There are material, some are hard to stretch or compressed, some are soft to stretch or compress. So this is related to elasticity. So what is elasticity? Elasticity, it is that property, it is what it is that property of the matter or the material or the object due to which it regain its original shape and size after when the deforming force is removed. After when the deforming force is removed. After when the deforming force is what? The deforming force is removed. This property is called the elasticity. Elasticity is the natural property of all the material. Natural property, it is what? The natural property of all substances or of all the material of the matter. Better to write of all the material. Better to write matter. Of all the material, irrespective of the question that less or more, we are not concerned with that. Okay, our concern is that material are elastic. Now few important point which I want to highlight to you is the first one is the deforming force. That what is the deforming force? So deforming force is the force, deforming force is the force which can distort the shape of an object. The shape of what? Of an object. And it may have many reasons, many effects can produce distorting forces. Here, what you see a force which your finger exert. That force we call sometimes stress, and it create what? And it create distortion. You look to the shape of the rubber band, and when you apply the distortion force, what happens to it? Like this one. Now when the body, when you remove this disturbing force, then the body quickly returns to its original shape and size. This property is called elasticity. Different material, different, different material, different material have different elasticity, different level of elasticity depends upon the nature of that material. For example, I would like to tell you that steel is more elastic than the rubber band in your hand, right? The question is why? Because sometime I just want to clear this to you that most of the time the students mistakes the word elasticity for stretching. Remember, note this point that note elasticity elasticity is not stretching, remember, or compression is not, yeah, elasticity neither is neither stretching nor compression. So when I teach this to the students, they say, sir, rubber is should be more elastic because it can stretch to the greater extent than the steel. The steel cannot be. So the reason is that we do not get the point actually. The point is elasticity is neither stretching nor compression. Rather, it is the natural property of the body to come back to its original position, shape, or size. Depends how quickly it does so. Depends on the nature of the material. The steel does it so quickly that even you don't notice any change. The sooner you apply the force and the quicker it regain its shape and size, right? Or I would like to say that maybe you need a tremendous amount of stress to observe the elongation or the stretching or compression of the steel. Clear? So this is one of the reason that steel is more elastic. Contrary to this, there is a term which I would like to introduce to you. Contrary to this is plasticity. Contrary to this is what? Plasticity. Now, what is plasticity? Plasticity is the failure of the body or objects, failure of the body or objects to perform the reversal process or to gain its original shape and size after when the deforming force is removed. To regain its what? Its original shape and size. Now remember, there is a limit for everything. Okay, even the elastic object may shift to plasticity, to the level of the plasticity. Why? If the object is, that is, if you cross the limit called the elastic limit, I just want to tell to you the about the elastic limit. Now, what is the elastic limit? That is, it is the limit beyond which beyond which the body is unable, the body is what? Unable to restore to its original shape and size. Shape and size, right? There occurs permanent deformation. We call this effect as the plasticity. Even when you remove the deforming force, remember, even when the deforming force the deforming force is removed. So if you even remove the deforming force, even then the body will be unable to come back to its original shape and size. For example, sometime when you stretch the spring, when you do it with a full force, then you notice that the turns of the spring, the coils of the spring get distorted and they are unable to come back to its original shape and size. And we say that there is plasticity. Even for the material, when you cross the level of the plasticity, you may reach to a breaking point. Okay, for certain material like hard material, the breaking point may come earlier than plasticity. For example, steel, when you apply a very high stress on the steel may break even before achieving the level of the plasticity, right? And we say that that is the breaking point. The question is that what are the causes of this elasticity? The causes of the elasticity is the change of the atomic lattice, or the changes in the atomic lattice or the shape and size. For example, let me tell you that all the objects, for example, if you have the objects, any objects, and you know that in the objects, like let me choose this. Okay, for example, that rubber band or whatsoever, naturally the atoms are arranged in a particular order and pattern, right? Elastic material are just like students, they don't like to compression and too stretching. If you allow them free, they will become too free or too loose, and if you just compress them or if you are hard on them, then they just complain about it. So the same is the case with the molecules. They neither like compression nor like what, nor like stretching. Okay, there is a kind of attractive force which keep them in a balanced position, right? So when you apply the external force, right, then what happens, that atomic lattice get disturbed. So the elasticity may be due to various mm, uh, effect, right? And they so when you apply the force, the atoms do not like to be stretched and they just quickly come back to its original position. Sorry, when you compress them, when you remove your force, and then they quickly return to their original position again. So this is all because of it. Now the next topic is the stress. That what is stress? Let me do it uh, like from here. Okay, I just want to start from here. Okay, let me clean the board for you. See, like this. Now what is stress? Stress can be defined as stress. What is stress? Stress is the force acting per unit area of an object, per unit area of an object. Stress is actually what? It is that thing which cause distortion in the body. Stress causes what? Distortion. Causes distortion in the body. Causes distortion in the body. It may distort the shape of an object, that is stress. So stress is the force acting per unit area of an object. We call it the stress, right? So mathematically we can write stress equal as force per unit area. It is just the same as the pressure, right? And this stress, it is denoted by a symbol sigma, and it is force per unit area. And the stress is measured in Newton per meter square, since Newton is the unit of force and meter square is the area, the unit of the area. So if 1 Newton force acts on a body of area 1 meter square, then the stress will be 1 Newton per meter square. It is very much similar to the pressure, right? So that is called the stress. Stress bring about changes in the shape of an object, right? So that is what called the stress. Clear? The stress is, of course, a scalar quantity. It does not have any direction. That is very simple. Next is the strain. But here I just want to go back to this one. Look, for example, the area, this area here of your finger, or the rubber band, and the force which your finger exert, then they create what? There is area, there is a force, and what stress is created, and what that stress, what does the stress do? That distort the shape of that rubber band. Clear? The next one is the strain. Now, what is strain? Strain is usually we will study here the tensile strain, right? The strain is what? The strain is actually the shape in the tensile strain. It is the what? It is the ratio. It is the ratio in the change in the change in the length of an object. It is the ratio of the change in length, sorry. It is the ratio of, it is the ratio, very sorry, it is the ratio of the change in length of the change in length to the change in length, the change in length to the change in length to the original length of an object, to the original length of an object. The original length of an object. This is called strain. Since strain, it is a kind of distortion in the length of an object, right? When the length of the object changes, when stress cause the length of an object to change, we say that it is a tensile strain. There could be volumetric strain also, right? The volumetric strain, there is the change in the volume of an object due to stress, and there could be shear strain also. That is the area, the change in the area of an object due to what? Due to stress. right? So stress always produces what? Stress always produces the stress. What does it do? Produces strain. Stress produces what? Stress produces strain. Now let us do this here. Look, as you see, look at this spring here. There is no force acting on the spring. So the spring has some original length here is, let's say, L, or you may write L naught, the original length of the spring. What is the original length of the spring? The original length of the spring is the length of the spring when no force acts on it. Okay. Now, when you apply certain force, so you apply the force on area of an object, there is area and there is force, so there is stress actually. So what is here? Here is stress, force acting per unit area. And you see or you observe elongation in the spring. Do you see elongation in the spring? And we say that the spring has stretched to some level, and this is the final length of the spring, LF. Now, what is the distance, what is the length to which the spring is being stretched? This one, as you see, look here, from here to here. This is what? This is delta L. And what is this delta L, the change in length? It is L into what? LF minus L naught, the original length. So what we can write about the strain is the change in length. Strain is the what? It is the change in length. Change in length to the original length. To what? To the original length. Here, or the strain in length, it is denoted by epsilon. The change in length is delta L by L. So what is actually the strain? The strain, I would like to tell you that it is what? That it is the first of all, it has no unit, right? Has what? Has no unit. As it is the relation as it is the ratio between two similar quantities, therefore it has no unit. Second, how I can then define it? Is a pure number. Okay, what? Pure number, unitless. So it is in fact what? It is the fractional increase. It is the fractional increase in the length of an object, in the length of an object per unit length. Okay, per unit length under stress. Yeah, when stress is applied on it. When stress is applied, when stress is applied on it, right? So that is what? That we say that it is strain. Clear? The strain is the factors for the strain. That what are the factors which causes strain? As I told you that the strain may be here, as you have seen. Look, what causes the strain? This strain, it is caused by what? By the external load, which you see here. Look here, you are attaching what? You are attaching masses to it. Here the force is 0. Here the force is F. Here you have double the force, and you have seen too much stress, too much strain here change. So the factors for the strain are, number one, it might be external forces, external load, as we have attached are force, or we can say stress. Okay, that is external stress. It could be because of this external stress. This could be because of many reasons. For example, stress. Look, temperature changes. What? Temperature changes. For example, at a certain place, you might have seen cracks in it, which can be caused by too low temperature, or you might have seen entire distortion in the shape of an object due to the rise in temperature. So temperature is also not just responsible. There could be even the moisture can cause the strain in object. This is why strain is very important to study for the material, particularly in the design of the aerodynamics vehicles in the that is in the architecture. Like for example, if you want to design buildings, bridges, so all these factors must be taken into account. Moistures, chemical reactions, right? So these are the factors which can produce strain, and you know that strain is very dangerous. Just like if the stress produce strain, then the strain may produce stress also. For example, if you just see the two section of the railway tracks, for example, they if they if there is extension in the length, and then there will be what, there will be a force, and then there, as you know, the force will be on an area. For example, like if these are the two section of the railway tracks, for example, you see, look, the railway tracks, because you know the railway tracks is very long, and it is made up of what, these sections, iron bar or like that. So you see that, for example, if you don't provide this gap, this will what we will study in the next chapter, right? So what will happen, that it will expand because of high temperature, and it will exert, that is, when it expands because of the high temperature, then there is a strain. That strain will produce what, force per unit area. The strain may be small, but the effect may be very large, and that force will what, it will distort the railway track. In the railway track, or the section of the iron in the railway track may bulges outward or inward, and may derail the train. So this is why these factors are very important in the field of engineering, right? That we need to address them there. So this is what, these are the factors for the strain. So the next two topics are very important, and those two topics are the Hooke law and the Young modulus. And inshallah, the Hooke law and the Young modulus I will just do in the next lecture, inshallah. Okay, so for right now, it is enough for you. Okay, so inshallah, see you in the next lecture. That is very important, the Hooke law and the Young modulus. And Hooke law is actually one of the relation between stress and strain. So see you there in the next lecture. All right.